In this video I will refresh your memory how to divide decimal numbers. Long and short division formats will be written up side by side and compared. Pros and cons will be discussed as we move along, and we will do 3 examples. We will do a decimal number divided by a whole number. We will do a second one where a whole number will be divided by a decimal, and in the third example we will have a decimal divided by another decimal. And these 3 examples will be side by side, long division and short division format. Before we start any division, there's going to be a reminder. And this is the rule, the only rule that applies to dividing decimal numbers. And the rule is there can be no decimals in the divisor or dividend. There can be no decimals in the divisor or dividend. And maybe I should insert one more thing here. There can be no decimals with value. Okay, there can only be 0 in the decimal digits. There can be no decimals with any kind of digits other than 0 in the divisor or dividend. Now, what do I mean by that? This is what I mean. Our first example is, what's half of a half? What is half of a half? What's half of a half? Now, in terms of math, in math language, this is how it's written up in long division format. The 0.5 is to be divided by 2. In short division, it looks like 0.5 is to be divided by 2. Now, those dots placed one vertically above the other, and if you are familiar with those dots and you call them ratio and proportion, that's also very fine. But just to remind you, ratio and proportion at its core is still a division problem. So I understand why you would call that ratio and proportion, but it's still a symbol for division. And this is what I mean by this rule, that there can be no decimals in the divisor or the dividend. Okay, let me just this is the dividend, the number to be divided by, and this is the divisor. This is the divisor. 2 is the divisor here or there, and 0.5 is to be divided. 0.5 is the dividend. There can be no decimal numbers in either this or this other than 0. So this could be 2.000, that's fine, but this cannot be 0.5. There cannot be any numbers there in the decimal places other than zeros. So what do we do? Let me remind you here about a fact that works with divisors and dividends. Okay, here's a dividend, and here are the divisors, and here is the quotients. The quotient or quotients. Okay, this is the fact family here. 15 divided by 3 is 5. Pretty obvious, but we'll start with the obvious. I'm not trying to insult your intelligence, but this is just a reminder about a strange fact in divisions. So and that's a typo there, dividend. So 15 is a dividend, 3 is the divisor, and 5 is the quotient. Now, when we change the dividend and the divisor by the same amount, the quotient doesn't change. This is what I mean. When we say double that amount, double the dividend, and we double the divisor, the quotient will not change. Let's give it a try. Double 15 is 30, divided by double 3 is 6, and it's still 5. You can check it with multiplication. 5 times 6 is 30, or 30 divided by 6 is still 5. The quotient doesn't change when the dividend and the divisor are changed by the same amount. For doing decimal division, we'll need another number, not 2. What is going to be particularly useful is 10. 10 times, increasing numbers by a factor of 10. So let's go 10 times 15 is 150, and 10 times 3 is 30. When 150 is divided by 30, the quotient is still 5. The quotient doesn't change. Let's increase that by another 10, and let's increase that by another factor of 10. So we have 1500 divided by 300, and it is still 5. The quotient doesn't change. The result of the division doesn't change just because we upscale the dividend and upscale equally the divisor. Let's try downscaling, see what happens. So this is our original, the baseline. 15 divided by 3 is 5. So let's divide 15 by 10, and let's divide 3 by another 10. Let's see what we have here. We have 1.5 to be divided by 0.3, and it is still 5. When 5 people have 30 cents each in their pockets, all together they have $1.50. That's the grand total. Okay, 1.5 divided by 0.3 is still 5. If you do the same changes to the dividend and the divisor, the quotient doesn't change. One last is if we divide this number yet again by 10 and divide that number yet again by 10, we have 0.15 there, and if we divide that by 0.03, the quotient is still 5. The quotient still doesn't change. So let me flip back to the rule here that there can be no decimals with value in the divisor or the dividend. This is what happens to 0.5 divided by 2. Let me just put this one here, and it gets written up as, because we want to get rid of this decimal situation here, we have to multiply this by 10 and that by 10, so it becomes 5 divided by 20. So is this one 5 divided by 20. Now for long division, it's written down in this format that 5 is to be divided by 20, and that just gets written down the same way. 5 gets divided by 20. And let's get going with this long division here. And this is what I mean by this rule. You'll see it in action in a sec. Does 20 go into 5? No, it does not. So do write down the result there. Now what do we do? This 5 is essentially the same as 5.0 or 5.00. By adding extra zeros here, it doesn't change the value of 5. It's still 5. 5 is the same thing as 5.00000. You can write as many zeros as you like. All of those zeros will not change the value of 5. So that's what I mean by there can be no decimals in the divisor or dividend. This is the dividend. Now it has decimal digits. Yes, it has decimal digits, but those decimal digits are without value. But they are important for doing the long division, and those zeros, those invisible zeros, are needed to finish this long division. But there cannot be anything else here other than 0. 20 then goes into 50. How many times? Twice. And now we also have a decimal point here that we passed, and this is why I like long division, because the decimal point just carries up vertically. These are the ones, these are the 10th place value figures, and the decimal dot just stays there and carries up. Let's multiply back. 2 times 0 is 0. 2 times 2 is 4. Let's subtract. 0 minus 0 is 0. 5 take away 4 is 1. And drop down the next invisible 0 from there. 20 then goes into 100, and it does so 5 times. 5 times 0 is 0. 5 times 2 is 10. 100 minus 100 is nothing. No remainder. Let's see how this works in short division format. Does 20 go into 5? No, it does not. And this is also a 5.00, however small those zeros are. So then 20 has to go into 50, and I dropped down an invisible 0 there. Let me just zoom in. You can see it's a very small drop, but it is there. We also passed the decimal point there, and the decimal point has to be placed over there. Let's zoom back out so you can see the rule and the division going. 20 goes into 50 twice. 2 by 0 is 0. 2 by 2 is 4, plus 1 more will make 10. Sorry, plus 1 more will make 5. The invisible 0 drops down there, and now 20 goes into the 100 and does so 5 times, and 5 times 0 is 0. There's nothing to be written down there. And 5 times 2 is 10. We already have the 10 written there, so nothing else gets written down here for short division. And that's the quotient, and that's the quotient. Oopsie. Now let's take a look at the original question. What's half of a half? Half of a half is a quarter, and this is how we work it out on paper with long division, and with short division it's the same thing. Half of a half is a quarter. And look at the rule again. There can be no decimal with value in the divisor or the dividend. So we started with 0.5 and we made 5 out of it, and then we had to add some decimals to it, but those decimal digits are without value. Okay, so this rule is extremely important. Let's take a look at example 2. Sorry guys. When we divide a whole number by a decimal, and let that whole number be 2, and let's divide it by, I don't know, 0.41, a 2-digit. So you can see a 2-digit decimal situation here. The same for short division. 2 is to be divided by 0.41. None of these can be done as is, because there is a decimal digit, 2 decimal digits with value other than 0 in the dividend. Now we have it in this number, sorry, in the divisor. So to get rid of that decimal digit, we have to multiply it by 100, and this becomes 200 divided by 41, and it gets written up as 200 divided by 41. Same thing here, 200 divided by 41 equals And let's get started with the long division. Does 41 go into 2? No, it does not. Please write the number there, write the number 0 there. It's very important that it keeps a place there for the quotient. Does 41 go into 20? No, it does not. It's very important that you write another 0 there. Don't forget it. If you come to class and I don't see those zeros, that's an incomplete and an incorrect. Next, 41 goes into 200. It does go into 200 about 4 times with a little bit of remainder. Let's multiply back. 4 by 1 is 4. 4 by 4 is 16. Let's do the subtraction. That's why long division has all the subtractions in it. We cannot take away 4 from 0, so we have to borrow to make it 10. We have to borrow from this 20. And if we borrow from that 20, this 20 becomes 19. So I'm just going to pencil it in. Let's just zoom in a little closer so you can see my 19, because I just penciled it in. Yeah, it's kind of faint, but that's what pencils can do. So we have, instead of 2, 0, 0, we have 1, 9, 10. 10 take away 4 is 6. 9 take away 6 is 3. 1 take away 1 is 0. I prefer seeing the zeros there to indicate that these are the hundreds here for this division, and those place values are preserved meticulously. I really like seeing those ones. And now the number here written up is 200, and it is actually a 200.000. Again, we turn this one into a decimal number again, but going back to the rule, now it doesn't fit the screen, but I'll do it this way. Here is the rule: there can be no decimals with value in the divisor or dividend. So we added zeros, and the zeros have no value, but they are important there because one of them is needed there to make it into 360. So now 41 goes into 360, and it goes into it 8 times. And one more thing, we just passed the decimal dot there, so it has to be placed directly above it in the quotient. The decimal dot must line up with the decimal dot in the divisor. Sorry, in the dividend. Now 8 times 1 is 8, and 8 times 4 is 32, and we'll do the subtraction. You know what, instead of borrowing from that 60, I want to count up from 328. To count up, from 328 we need 2 to get to 330, and from 330 to 360 we need 3 there, and that's a 0. Next decimal, not decimal, next invisible 0 drops down. 41 goes into 320. How many times? It's about 7. I'm just gonna make that line longer. It's about 7 times. Let's multiply back. 7 by 1 is 7. 7 by 4 is 28. And let's do the subtraction. Again, I want to count up. 87 plus 3 will make 90, and 90 plus 30 will make 320. And there's a 0 there because it's 33 is just 33. We count it up. Counting up is the same way how bartenders give change. When you give them a bill, and that's how they count up to give you change. Okay, 41 goes into 330 about 8 times. Let's multiply back. 8 by 1 is 8, and 8 by 4 is 32. Let's subtract, and now you can see how counting up is easy. 328 plus 2 will make 330, so there's your remainder, as your zeros there for keeping the place values of remainders and everything. So the answer to the question, what is 2 divided by 0.41? The answer is 4.878 with a remainder of 2. Let's do short division real fast here. This one again is a 200.000, and 41 goes into 200 4 times. 4 by 1 is 4 plus 6 to count up to the nearest 10, and you have a 1 to carry over. 4 by 4 is 16 plus 1 is 17, so you're counting up from 17, 18, 19, 20. So that's 3 there, and that 0 drops down there for the next division. That's a super small drop, but it is there. We also pass the decimal dot, and the decimal point gets placed there in the quotient. 41 goes into 360 8 times. 8 by 1 is 8. To count up to the nearest 10 you need 2, and you have a 1 remainder because you reached the nearest 10. 4 by 8 is 32 plus 1 is 33. From 33 to count up to 36 you need 3. There's your remainder from the subtraction, which was counting up, and it drops down the next 0 there. 41 goes into 327 times. Let's multiply back. 7 by 1 is 7. To count up to the next 10 is 3. You have a 1 remainder. 4 by 7 is 28 plus 1 is 29. To count up to 32 you need 30, 31, 32. You need another 3. And then that 0 drops down there. 41 goes into 338 times. 8 by 1 is 8 plus 2 to count up to the nearest 10, and you have a remainder 1 from that 10. 4 by 8 is 32 plus 1 is 33. We are already at 33, so that's a 0 and a 0, and we'll just call it quits here. The quotient of this division is a non-repeating infinite decimal, so this could go on for all eternity. Please do not continue it for all eternity. The answer again to the question, what is 2 divided by 0.41, is that 4.878. And you can compare the same numbers appear in short division and long division. 360 there, 320 there and there, 330 there and there, and the remainder 2 there and there. And this is why short division is called short division. None of the subtractions are written up, only the results of the subtraction are written down. Lastly, to finish it super fast here, let's just zoom out a little bit. Just a little bit. Jolly good. We'll have the long division here and the short division here, and as I said, example number 3 will be a decimal divided by a decimal. So what is 0.3 divided by, I don't know, 0.71? Same in short division, 0.3 divided by 0.71. Like I said, these cannot be done as is, and you have to find the number with the greatest decimal digits, and you have to multiply the divisor and the dividend by the same number to get rid of the decimal dot here, and that number is 100. So when we multiply this one by 100, this becomes 71, and that one becomes 30, and the same goes there. 30, and this is gonna be divided by 71. Let's get started with the long division here. Does 71 go into 3? No, it does not. Please write the result there. Does 71 go into 30? No, it does not. Please write the result there. And like I said, we're going back to the rule. There can be no decimal digits in the divisor or the dividend other than 0. There can be no decimal digits there with any value. So then 71 has to go into 300, and because we're past the decimal dot, we are writing down the decimal dot there. 71 goes into 300 4 times. 4 times 1 is 4, and 4 times 7 is 28. Let's subtract, and I'm just gonna count up. 84 plus 6 is 290, plus 10 more is 300. Let's drop down that next 0 there for the division. 71 goes into 160 twice. 2 by 1 is 2, 2 by 7 is 14. Let's do the subtraction fast there, and we're counting up from 42. We need 8 more to get to 50, and from 50 to 60 we need 10 more. So there is the result of the subtraction. The next 0 drops down there. 71 goes into 180 about 2 times. Yeah, that's a 2. Okay, and just a little off, but that's a 2. 2 by 1 is 2. 2 by 7 is 14. We'll do the subtraction there. From 42 to go to 50 we need 8, and then we need from 50 to 80 another 30. So we have 3 decimal digits there. That's good enough for now. It's another either repeating or non-repeating but infinite decimal number, so please don't continue it for all eternity. Let me just show you quickly the short division format. Does 71 go into 30? No, it does not, and this is a 30.000 as well. We have to go into 300. So we passed the decimal point, and we do place the decimal point. And 70 goes into 300 4 times. 4 by 1 is 4, plus to count up to the nearest 10 we need 6. And there's a 1 carryover. 4 by 7 is 28, plus 1 is 29. To get to 30 we need 1 more. And we drop down the next decimal, the next 0 there. 71 goes into 160 twice. 2 by 1 is 2. To make it up to the nearest 10 we need 8. And the 1 carryover. 2 by 7 is 14, plus 1 is 15. To count up to 16 we need 1 more. And the last invisible 0 goes there. 71 goes into 180 twice. 2 by 1 is 2. To count up to the nearest 10 we need 8. And 1 carryover. 2 by 7 is 14, plus 1 is 15. From 15 to 18 we need 3 more, so there's your 38 remainder. Long division, short division, side by side. So the answer to the question, what is 0.3 divided by 0.71? The answer is 0.422 in both versions. Basically, that's how to deal with decimal divisions. Is not a lot different from long division or short division with whole numbers, but there is an extra step in it, that there cannot be a decimal number other than 0 in the divisor or the dividend. Of course there will be, and there can be, decimal digits other than 0 in the quotient. So keep practicing.